Okay, today we're going to talk about parallel lines, and parallel lines are lines that have the same slope, alright? And these two depictions here, these two pictures show, first on the right side, that any two vertical lines are going to be parallel to each other, just like any two horizontal lines will also be parallel to each other. And remember, parallel means that the lines will never cross, and that's something we've learned a while back, but now we're going to take it just a little bit further by using slope. Okay, so if we look at this first graph here, they give us two equations in slope-intercept form. Y equals 1/2 x plus 5 and y equals 1/2 x plus 1. So their slope, they kind of use some weird, they go by twos is what I'm trying to say. So 2 and then -2. Alright, so if I look at the red equation, if I go up 1, that's right there, that is my slope, or that, not my slope, that's my y-intercept, and then from there I would go over 2, up 1, and I would get this point. Same as if I went up 5, so it would be up, there's 2, 4, 5 would be right here, in between, this is 6, and then I would go over 2, up 1 from that point, and we get the same slope. So we can see that the same slope means we're going to have two parallel lines. So it's really easy to identify with two equations if you have two parallel lines. You just have to compare their slopes. If the slopes are the same, then you have parallel lines. Of course, we've got to make it a little bit more difficult though. Here they give us 4 different equations. And they want us to figure out which one of these are parallel to each other, if they are at all. Okay, so let's take a look here. The best way to do this is to put things into slope-intercept form. Well, this equation right here, the first one, is already in slope-intercept form. This has a slope of 3, which is right there. Okay. The second equation is also in slope-intercept form, and this has a slope of -1/2. Okay, so we have to manipulate these last two here to see. If we notice, I'm going to jump to the last one. This particular equation is in point slope form, meaning I do have a slope of 3. So it's tempting to say that the first equation and the last equation are parallel. They do have the same slope, but let's just do a quick little manipulation here. Let's solve for y, just kind of like we've been doing recently. So I'm going to distribute y minus 5 equals 3x, 3 times 1 I get -3. And then I would just add 5 to both sides. And we end up getting y equals 3x plus 2, sorry. And we'll notice that actually this equation and the first equation are the same. If you ever have the same equation, they're not parallel to each other, they're just the same line. Okay, they're on top of each other. So not necessarily parallel. So we wouldn't say that they are in this case. So lastly, let's take a look at the middle equation. If I solve for y here and put it in slope-intercept form, then I can tell what the slope is. So I'm going to subtract x on both sides. I'm left with 2y equals -x minus 4. And then I have to divide everything by 2 to solve for y. And here's what we get. Y equals -1/2 x minus 2. Since -4 divided by 2 will give me -2. And that's this equation. So this has a slope of -1/2, meaning these two equations are parallel. And there we go. So that's how you can manipulate some equations to find out if they're parallel or not. So you can't just go by first glance, you have to manipulate them a little bit. And lastly, last example here, this is going to look like something we've done with point slope form. That's why point slope form is important. They want us to write an equation in slope-intercept form for the line that passes through this point and is parallel to this line right here. Okay, so if we're going to be parallel to this line, we need a slope of 5. Right? Because parallel lines have the same slope. Well, now we have a point that's going to be on our line, and we know what the slope has to be. Sounds a lot like point slope form. so if we can plug something into point slope form, we're solid here. So I'm going to take y minus my specific y, which is 5, set it equal to my slope that I need, which is 5, and x minus my specific x, which is 4. And then we've got just a little bit of manipulation. We're going to put it into slope-intercept form as they want it right there. So 5 times x and 5 times negative 4 gives me negative 20. And then we just have to add 5 to both sides. And here we go, y equals 5x minus 15. This equation is parallel to the given equation and will also fit the point 4, 5. And that is what we would do in that situation. We'll talk more about that tomorrow. Alright, that's all I've got.